Hello, how you doing, everybody? It's Musa do the math, and today we're going to talk about graphing absolute value functions, right? Absolute value functions. First and foremost, let's kind of review absolute value, like where we started, right? So if we let's look at an equation from yesterday, all right? So y equals 2 times the absolute value of x plus 2 minus 1. And in this equation alone, we can find out everything we need to be able to graph it, right? And today we're going to talk about identifying the domain and the range of these particular functions. All right, first and foremost, on the inside of this absolute value bars, we have our x minus h being the x of the vertex, and on the outside we got the plus k being the y of the vertex. And so if we look at this, everything inside of the absolute value bars are opposites. So if it's negative on the inside of the absolute value bars, it's going to be positive when we talk about identifying it as this x value. But outside of the absolute value bars, whether it be positive or negative, tells us what it's going to be on the outside. So if it's positive, it's going to be positive. If it's negative, it's going to be negative. So if we look at this particular problem here, where we have the absolute value of x plus 2 minus 1, the plus 2 means that the h is going to be negative 2 and the y is going to be negative 1. So our vertex would be negative 2, negative 1. All right? All of that, everything from the absolute value bar to the right, is this the right? Yeah, to the right tells us what we need to know about the vertex. Now, on the left side of the absolute value bars, it tells us everything we need to know about the next points as we find further points past the vertex. And so if it's positive, the absolute value is going to open up, open up. So it's going to look like this. If it's negative, it's going to open down. So it's going to look like that, right? And so essentially, this number here is the slope of our vertex, right? And absolute value functions is actually just 2 lines starting at a vertex, all right? So this is a line, x plus 2 minus 1, right? It's a line going in this direction, and then it's going to be going in the negative direction, right? So this 2 represents from the vertex, it's going to go up 2, and it's going to go to the right 1 in this direction. And over here, it's going to go up 2, and it's going to go to the left 1 in this direction. You have a mirror situation. So that's essentially how we graph these. And today we're going to talk about identifying the domain and the range. We're going to talk about the x-intercept and the y-intercept of it. Okay? So now let's look at it. The domain, we talked about this a chapter ago, right? The domain is the x value, right? It's a set of x values. The domain is the x value, right? Whereas you plug the x value in and you get y values when substituted into a function, right? Visually, that is how your graph moves from left to right. So the domain is how your graph moves from left to right. From left to right, right? That's how it moves, right? And so, with absolute value functions, this arrow, whenever you see an arrow at the end of something, that means it keeps going on and 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 on. So, that's what happens when we're looking at our domain, the left and the right move of the graph, right? For your range, that is your y values. Right? That's your y values. And visually, that's how your graph goes up and down. It moves up and down, right? So it's your vertical movements, right? And so visually, like from the vertex is how your graph goes up and how your graph goes down, okay? Now, when we're looking at functions when we're looking at linear functions, absolute value functions, and quadratic functions in particular, that's where we're going to stop at right now. And for real, cubic functions, right? The domains are pretty much the same. All right? So, we're going to talk about those domains, right? So the domains are pretty much the same. Because they're going to always be going from left to right, the domain for all of these is always going to be all real numbers or going from negative infinity to positive infinity, right? So keep that in mind. So for your domains of these type of functions, linear, absolute value, quadratic, and cubic, the domain is always going to be all reals. That means all the numbers. And negative infinity, positive infinity. So let's look at this even deeper. All right, so let's look at number one. Number one, y equals the absolute value of x minus 4 plus 2. All right, we just talked about this. All right, so first things first, I want you to graph this. We're going to graph this. All right, what's the vertex?
Negative.
H is 4. Okay, right, so the vertex is 4, 2. Right? Good. We got that. How is our graph going to move? Right. There's no number here, so it's going to go up 1 and to the right 1, and it's going to go up 1 to the left 1. Right? So let's sketch it. Well, I'm going to sketch it. You can actually graph it because you got this situation. So 4, 2. 1, 2, 3, 4, up 2. 1, 2. Right? There's our vertex, okay? There's our vertex, 4, 2. And then we're going to, because this is positive, it opens up. So we're going to go up 1, bow, over 1. Up 1 to the left 1. And you can do it again if you wanted to, right? Yeah, up 1, over 1, right? Yeah. All right, so this is pretty much our graph, like that. And like that. That's what it's going to do. Notice that we got these arrows here. Arrows mean it's going to keep going forever and forever in both of those ways. Okay? Now, let's look at our notation. So we want to find our domain and range. We have two types. We have inequality notation and we have interval notation. Okay? For inequality notation, right? The domain is going to be all real numbers. All real numbers. Right? It's going to go from negative infinity to positive infinity. Right? So, inequality notation has the range. The range, we always start with the range. We start at the y of the vertex, right? We start at the y of the vertex, so we're looking at the k. The range starts at the k. All right, so here, our vertex is 4, 2. So we're focusing on this 2. All right, now from 2, which way does your graph go? Does it go bigger than 2 or does it go smaller than 2? Bigger, because it's going up, right? So for inequality notation, your range is going to be y is greater than, and it starts at 2, or equal to 2, or greater than and equal to 2. So it's going to be 2 and everything past 2, right? That's for inequality notation. Interval notation basically is going to tell us how it's going to approach infinity, right? So for the domain of interval notation, it's going to approach negative infinity and it's going to approach positive infinity because it's going to go forever. It's going to go on and on again, on and on again. All right, now for the range, it's going to start at the y. It's going to start at 2. Start at 2 and it's going to go up, right? So it's going to go from 2 to positive infinity, okay? So here's something that can help you if we still kind of struggle with the infinities. On the right side of your coordinate plane, put the infinity here, and at the top of your coordinate plane, put positive infinity there. And then on the left side of your coordinate plane, put negative infinity, and at the bottom, put negative infinity. So you know that, that's what your graph is doing. It's approaching positive infinity and negative infinity. And here it's approaching positive infinity. So these are your notations. Everybody good so far? All right? You all start doing number 2, and I'm finna do it too. All right? Let's look at the second one. All right? You try to beat me to it. So y equals negative 3 over 2 times the absolute value of x plus 5 plus 4. Okay? H is 5, right? And K is this one. But again, inside of the absolute value bar is the opposite, right? So our vertex is what?
Negative 5 and 4.
Negative 5, 4 is our vertex. Okay? Now, figuring out how our equation is going to move, or our function is going to move, you look at this negative 3 over 2. That means we're going to go down 3 and to the right 2. And we're going to go down 3 and to the left 2. Okay? So that lets us know, again, when it's negative, it's going down. I'm going down. All right. So, here we go. We're going to go down. Vertex, negative 5. Bop, 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 bop. Positive 4. Bop, 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 bop. So, here's our point. That's our vertex. Right? Based on our slope, the front of the absolute value, we got negative 3. 1, 2, 3 over 2. Right to the right. And then here, 3, 2 to the left. Right there. Right? And we're going to draw our arrows. Alright? So, let's talk about our notation, our domain. So again, the domain is going to approach negative infinity. You see these arrows here. And positive infinity. So that's going to be all real numbers. Okay? The range, however, is going to start at 4. Right? So it's going to start at 4. And is it going up or down? Up. So we need numbers less than 4. Right? So it's going to be y is less than and equal to 4. Everybody see that? Because underneath 4 is 3, 2, 1, and it keeps going to negative infinity. Okay? So for interval notation, that's going to be negative infinity to positive infinity. Right? And for your range, it's going to be negative infinity to 4. Negative infinity to 4. Need a box here and a parenthesis. Alright? So that is how we find our domain and our range of absolute value functions. Alright? How y'all feeling so far?
Good.
Feel alright?
Yeah.
Alright. Let's flip it over. Let's talk about intercepts. Intercepts. Alright? The x and y intercept of absolute value functions is the same as the x and y intercepts of everything, of anything. Alright? So with that being said, what is the x-intercept? How do you find x-intercept? You make what?
Y 0.
Yeah, absolutely. So that's what happens. X-intercept is when y equals 0. And the y-intercept is when what? X equals 0, right? So what we have to do is we got to plug it in, all right? So steps of finding the x and y intercept are the same for every function. They're the same for every function. All right, so let's look at this problem here. Find the x-intercept and the y-intercept of each function, all right, if possible. And you can make a rough sketch. All right, so let's look at this one. So we got y equals 2 over 3 times the absolute value of x plus 7 minus 4. Okay? All right. First things first, let's find the x-intercept. Okay? Finding the x-intercept means that we make the y 0, right? So for the x-intercept, we're going to do 0 equals 2 over 3 times the absolute value of x plus 7 minus 4. Here's where it gets tricky, right? We got to go all the way back to our first chapter in solving absolute values, right? When we solve an absolute value function, we got to get this absolute value bars by themselves. So the first thing we need to do is move this 4 over, right? So we'll have 4 equals 2 over 3 times the absolute value x plus 7. And then we got to move him over, right? So we got to multiply both sides by 3 over 2, right? multiply by the reciprocal, right? So now we don't have this anymore. All right, 3 over 2 times 4 is going to be 12 over 2, which simplifies to be what?
4. What you said, 12 over 2? 6.
6. So we got 6 equals the absolute value of x plus 7. All right, now, thinking about last chapter, or 2 chapters ago, when the absolute value equals a positive, how many solutions do we have? 2 solutions. Very good. That means we got to solve for x, for 6 equals x plus 7, and negative 6 equals x plus 7. All right? So you get 2 solutions. Okay?
Yeah.
You good, Ethan? Yeah. So remember, let's think about it. So when the absolute value equals positive number, you get 2 solutions. When the absolute value equals 0, you get 1 solution. And when the absolute value equals a negative number, you get no solutions. Y'all remember that? Yeah, I'm forcing you to remember this. All right. So when we solve, we're gonna subtract 7 from both sides. X equals negative 1 here. Here we subtract 7 from both sides. X equals negative 13 here. Right? So those are our x-intercepts. Right? Negative 1, 0. Negative 13, 0. Those are our x-intercepts. Okay? Our y-intercept's a little more, it's a little smoother, right? Because we don't have to do solving. We just simplify, right? So for the y-intercept, again, we got y equals 2 over 3 times the absolute value of x, 0, plus 7 minus 4. In a problem like this, we just evaluate, right? So it's going to be 2 over 3 times the absolute value of 7 minus 4. The absolute value of 7 is 7. So we just multiply that one, right? So now y will equal 14 over 3 minus 4. Okay? 14 over 3 minus 4. Just like earlier today, we can't add fractions and whole numbers. I mean, we can, but in order to do that, we need a common denominator here, right? So the common denominator would be what here? 3. So we got to multiply top and bottom by 3, right? If we don't have our calculators to do all the work for us. So we get y equals 14 over 3 minus 12 over 3, which gives us what? 2 over 3, right? So our y-intercept is 0, 2 over 3, right? Or 0, what, 0.6 repeated, right? So here's our x-intercept and our y-intercept, right? So we essentially have 4 points. We got our vertex. What's our vertex? We didn't even talk about it. What's the vertex here?
Negative 7, 4, negative 4.
So we got 4 points. We got the vertex, negative 7, negative 4. We got our x-intercept, 1, 0, negative 13, 0. And then we got our y-intercept, 0, 2/3. All right, we can plot all of those and we got our graph, right? All right, tell me this. Is it going to open up or down?
Up. Open up, right?
Why is it going to open up?
It's positive.
What's positive?
The number is the slope.
The number on the left side, right?
Yeah.
So it's a positive, it's going to open up. So you're going to start at here. We're going to start at negative 7, 4, and we're going to go up. All right? Everybody good so far?
Yeah.
All right, cool. Let's do one more, and then I'll leave you alone. All right? I think we got enough time. We get out of here. 55?
Yeah.
We got 3 minutes? See if we can do this in 3 minutes.
2 minutes.
We got 2 minutes?
Yeah.
All right, here we go. Let's go fast. Y equals negative 2 times the absolute value of x plus 8. All right? The y-intercept is going to be 0. So you got negative 2 times x plus 8. Right? Subtract 8 from both sides. And we're going to get negative 2 times x. Divide by negative 2. We're going to get 4 equals x. Right? So, again, it equals a positive, so 4 equals x, and negative 4 equals x. That's our x-intercept. Our y-intercept is going to be 1 y equals negative 2 times 0, 0 plus 8, right? 2 times 0 is 0, so y equals 8. So our y-intercept is 8. All right, so we got 0, 8, 4, 0, and negative 4, 0. Those are our 3 points. That was really, really fast. All right. So again, this is how we deal with graphing absolute value functions and finding the domain and the range. If you have any other questions, comment below. And if you haven't already, don't forget to like and subscribe. Until next time, let's do the math out.